Hello and welcome to today's Teardown Sessions. We've got one of my favorite repeat guests on today, Joey Castillo, who is the creator of the Sensor Watch, as well as lots of other exciting open hardware, some of which we'll even be getting to have a look at today. So that's very exciting. But before we bring him in, I'm going to quickly show you what's going on in Crowd Supply. One moment. All right. So let's bring that on here. Here we go. So crowdfunding currently at Crowd Supply, we have the Sharpie Keybow, which is done by Morpheans, which is a lovely little open hardware Linux computer with a QWERTY keyboard. Very small little handheld situation there. And that's about halfway through the campaign, and it's about 40% funded. So if you want a tiny purple Linux computer with a QWERTY keyboard, you should definitely check that out. Look how little that is next to a Raspberry Pi Zero. So it's a cute little QWERTY thing. So that one's a fun one. 13 days left to support that. And another one, another little project here from the delightful Leon Anavi, who was in fact my first guest on this stream and will be coming on in the delivery phase of this to show you some of the exciting things that it can do. That one's got 18 days left. So if you want to support Bulgarian open source hardware, go ahead. It's a very not too expensive little buy there for your Raspberry Pi add-on. So take a look at that if you're interested. I also wanted to shout out a couple of upcoming projects that are getting ready to launch their campaign. We've got Bean Counter by the delightful Nick Poole, who, if you are a regular watcher of this show, you will know he was on there. He was on the Teardown Sessions a couple of weeks ago, sharing some of the exciting prototypes of this. So you can skip back in time and watch some of the conversations we had with him. He's a very interesting guy, works at SparkFun, and this is his first personal project. So if you want to support this, it's a lovely, I'm going to buy one for my electronics bench. It's an SMD cut reel counter, which sounds like something everybody needs on the bench. So that one's coming soon. Very excited about that. Also coming soon, I wanted to give a shout out actually to two projects that are coming soon that are A, both music related, and B, both projects that I first came across at hardware happy hours. So this is a pocket integrator. I came across, I found the creator of this and chatted to him at the Portland happy hour. Hardware happy hour, which was really fun. I got to play this. It's an add-on board for a pocket operator. And if you're not familiar with a pocket operator, they're a fairly ubiquitous, Teenage Engineering is the name of the company that makes them, hardware people in Sweden. And they make these cool little pocket-sized synthesizers that do various different things. And what this is an add-on board that you snap onto that your pocket operator, and it's got a little IMU on it, so you can shake it around, you can tap out the rhythms. It's just it's so much fun to play with. And if you do already have a pocket operator, or this sounds like something you might get into, I would definitely check this out. I've had to play with this; it's great fun. Another thing I've had to play with, and that's great fun, is the Quadrant. And I saw this at the last Seattle hardware happy hour that I went along to. A hardware hacker there called Chris, who's made this. It's basically like a Leap Motion style thing. It's a hand tracking interface. And I've seen really great examples of this being used with the open source music software, Pure Data. Some really great stuff on the internet. And I'm really, really happy that this is coming to the market finally, as opposed to just being a project on someone's bench. So I'm very, very excited for this one to launch. I'm definitely going to buy one of these as well. As the last two coming soon projects I talked about were both ones I found at Hardware Happy Hour, I feel like it's a good time to plug the next Hardware Happy Hour. So I run Hardware Happy Hour in Portland, and we've met up a couple of times. And the next meeting is going to be on the 26th of July at the By and By in Portland. Everybody brings projects, we share things, we talk about components that we're desperate to find, and they're unobtainium. So basically, it's just a social hangout, no presentations, no roller banners, literally just nerds talking to each other about their hardware projects. And yeah, we have a group here, so you can go along to here and join up for the group. The details for the upcoming Hardware Happy Hour aren't public yet because I'm just waiting on the venue to confirm the table booking. But all going well, it should be on the last Tuesday of July, which is, I believe, the 26th. So if you are local, please do join us. And the last thing I wanted to give a shout out to before we get our guest on today, Joey Castillo, is Microchip Get Launched. So Microchip get blah, blah, words, Helen. Let's try and say sentences in the order in which they're supposed to be said. So Microchip Get Launched is a launch program that we have at Crowd Supply. So if you are considering running a campaign with Crowd Supply, we do have a number of these different launch programs with various chip manufacturers. And what they do is if your BOM, your bill of materials, uses one of your hero components lines up to one of our supplier launch programs, then you get money off of your crowdfunding campaign. So it's like subsidized by these companies, basically. Plus, they give you extra marketing support, particularly Microchip, actually. Microchip are very good at supporting creators who use stuff, who are on their program. They tweet about them and all sorts of things. It's a good little program. So if you are thinking about it and you are considering your BOM, do think about Microchip Get Launched. There's all sorts of fun things. And in fact, our guest today, this is a good segue, isn't it? Our guest today, wait, I'll show you this is the URL there. So our guest today is actually part of this program, Microchip Get Launched. So let me remove this. And then I'm going to bring on Joey. Let's see if we can bring you on. Hello, Joey.
Howdy.
Nice to see you. Howdy. Sound and video. This is exciting. Oh, by the way, everybody who is watching, I forgot to say about the mystery hardware box, my goodness. So if you are, there's a weekly giveaway of a mystery hardware box, and there's all sorts of swag and hardware in here, but there's also something very special that's actually not in here, it's in my luggage. But Joey has given us a special edition sensor watch to give away. Ooh, so very exciting. So not only do you have your normal swag and random hardware, mystery hardware, and you're also going to get a special edition sensor watch. So the way that you win this is by commenting and asking questions and giving comments during the stream. And if your question or comment is closest to the timestamp that I have on this piece of paper, then you will win the whole shebang. So please do keep your questions and comments rolling in. It also helps us feel less alone, and we like to hear what you have to say.
I'm really excited about that one. You can't get the special edition sensor watch anymore. The blue ones are all gone. So yeah.
Oh, very exciting. Very exciting. Yeah, I do. Actually, I do know where it is. I was looking for it earlier, and I was like, I know I had one. But I can't remember where I packed it because Joey gave it to me at a hardware happy hour in New York. And I brought it home with me in my luggage, and I was like, I don't know where it is. But now I've just remembered. Well, live on stream, I've just remembered where the sensor watch is. So that's that is a good thing. All right. So Joey, for those people who don't know you, would you like to introduce yourself and say a little bit about your work, what you do?
Yeah,
fantastic
sure.
Things that you do.
Thank you. So I am Joey. I run this thing called Oddly Specific Objects. It's kind of a hardware engineering making thing. I try to make open source objects that kind of explain themselves and help people to understand how the gadget works so they can feel empowered to make their own gadgets. So the project that I've launched with Crowd Supply is the sensor watch. It's actually this little tiny green circuit board that fits inside of tiny green circuit board that fits inside of this Casio wristwatch. So it basically takes your Casio wristwatch and it turns it into a smarter watch, not quite a smartwatch, but reusing the old low power display, reusing the same buttons on the side and the little beep beep piezo buzzer. And yeah, it's continuing apace. We're manufacturing next week at Cyber City Circuits in Georgia. And
ooh, nice. How fun.
I was hoping they could come on and share some footage from the manufacturing floor, but I think they're doing some DEF CON badges today. So they're going to do the sensor watch first thing next week.
That's exciting. That's exciting. Oh, they're good people as well. And for those of you who haven't seen it, we actually did a factory tour of the Cyber City Circuits workshop while Joey was doing your prototypes. That's correct. Well, it was the first run, right?
It was the first run. It was the special edition board.
Yeah. So actually, we have documentary evidence of those sensor watches. Those first sensor watches being created.
Yeah, they made 40 boards, 4 panels, literally on the stream. Like we ran, not just for show, we were manufacturing.
We did. It's true. I mean, it's one of my favorite streams. Actually, I just really enjoyed sitting back and watching the process. It was really fun.
As a side note, that was back in November. I believe it was.
Yes.
Yeah, November. And that was when I started the battery test on this watch, which is 242 days in. So
Tell me more. So I already know about this battery test, but for people who don't know about it, tell them what you've been up to with your battery testing. It's really fun.
So the gist is the SAML 22 by Microchip is a really low power microcontroller. It's really good at kind of sipping very small amounts of power. So that's really useful when you have something like a wristwatch. The thing, like, I don't even wear a smartwatch anymore because I was tired of recharging it every day or every other day. If you put a coin cell into this thing, it should last for a while. And the only way to test it out for sure was to put a coin cell in it and see if it lasts for a while. So I loaded up a fresh battery back in November, and the goal was just to see how long the battery would last. And it's still ticking at day 242.
Very cool. Very cool. That's very exciting.
And then this is actually interesting.
242 on one single coin cell battery. Is it like a what battery does that actually use? Sorry,
it's a CR 2016. So yeah,
2016. Okay.
Yeah, 100 milliampere hours is the capacity on that. So you got to like just really meter it out. But the other cool thing is this is actually running an older firmware that was not as power efficient. Oh. So the new one I've got on my wrist here is what day are we at here? 137, and it is actually sitting at above 3 volts still, almost 140 days in. So this is going to be at least a year of battery life. I'm curious to see how much further it goes.
That's really exciting. All right, I want to take a quick break to see who's in the room with us, because we've got a few people who are saying hi. So we've got Guy Dupont who's joining us. Hi, Guy. Nice to meet you from Massachusetts, UA. MA is Massachusetts, right? Am I not? Or am I making that up?
And that's Massachusetts.
Right? Massachusetts. Okay, good. I'm still learning. It could have been Maine. It could have been Maine. What's this? I don't understand what you're asking, David. So let me know what you're asking here. I'm not sure about the click track, what you mean. And then Johannes is saying hello, hi. And then someone here from Tampa, Florida. Hiya, Michael. Thank you for joining us. And some love from Hardware Happy Hour. I love Hardware Happy Hours too. I run the Portland one, but I started the one in Berlin as well, and I've run them in various other places. And I've even been to, like, the Chicago one was the original one, set up by Chris Gamble and Drew Festini, and it's just such a nice concept. It's like a low pressure way to hang out with other hardware nerds, so that's really fun. Obviously, here's David here from Ann Arbor in Michigan. There we go. And Thomas from Finland. Nice to see a European in the house. We like it. Amazing segue. Thank you very much. Yes. My first compliment for the giveaway system. Good. I'm glad you like the giveaway system, because it's very non-technological. It's just written on a piece of paper. And also Noah saying that they're very, very excited to hear from Joey.
Cool.
Oh, wow. Lots of people here today. This is great. So I do have a question here. So from Benny saying, do you have the graphs of the battery?
I do, actually. We have.
I know you do.
Yeah, let me share my screen here.
If you share the screen, I can add it in.
I hope that's screen 2. And I will need to. Crowd supply, sensor watch. It's actually in the macro
the most recent update.
Yeah.
Oh, isn't that handy? Here we go. Oh, you just published this one too, didn't you?
We just published this yesterday. I had to make some modifications to the scale of the graph because we're using so much less power than the factory test. But yeah, that's the red line represents this kind of gray toned watch. And the green line represents the one that I've been wearing on my wrist, the kind of shiny one. And yeah, that's showing
the one with the new firmware, right?
The one with the new firmware. And you can see where the more power something consumes, the more of a voltage drop it'll cause in the battery. So the fact that after all this time, it's not even like, it's still so much higher voltage. So much higher, 3.06 versus 3.0. But that is showing us that the current draw is lower, and I'm expecting that line to extend out significantly further before it starts to curve down.
It already looks pretty amazing, Joey.
That's
quite a good graph. Yeah, I'm stoked. Like, I remember seeing the experiment in November and wondering how it was gonna. It was. I know, that was hilarious. Sorry, Johannes says we don't waste back money on graphic design software. I see. What do you mean, Johannes? What are you insinuating here? Because all I see is extremely professional graphing.
You know, that is
definitely
one of the
not just an MS Paint.
I think one of the things in my practice is I kind of like the idea that you don't need like fancy stuff to make things. You know, this is just drawing on a graph. It works.
It's true. It's true. You are right. You are right. Oh, a good question here, actually, a follow-up here is, what is the big change in the firmware to reduce the power consumption?
Ooh, I should find this thread and post about it. If we have a break, I'll find it. Essentially, I went through, actually, when was this? It was in February. I was looking at the battery consumption. I was like, it was 30 microamperes in wake mode and about 11 or 12 in sleep mode. And I was like, where is that coming from? Because I know the microcontroller can get a lot lower. And basically, I ended up figuring out there was a configuration where I could, it's basically how often the microcontroller checks the LCD voltage. And basically by lowering the frequency of that check, I was able to, lower the consumption in sleep mode. And in wake mode, what was it? There was, there was some subtle misconfiguration of my external interrupts. Basically, I was clocking the external interrupts, which is the buttons. I was clocking that from the external crystal, but you can actually clock that from the low accuracy internal oscillator. And it's very in the weeds, but it ended up being of significant savings in power consumption. And it doesn't affect the accuracy because you're only worried about the buttons there. It's not actually the low accuracy of the crystal or the oscillator doesn't affect the high accuracy of the crystal for the timekeeping. So
yeah, for sure.
Too much information. Sorry, word vomit.
No, this is the place for too much information. This is definitely, look, if there was ever a live stream where too much information is encouraged, this is the one we like to get. Well, another follow-up thing saying, is there any RTOS running in the watch?
No RTOS. So this is just a bare metal firmware I've written in C. And we actually, I probably have the window open.
I've got your GitHubs.
Yeah, here we go. So the GitHub repository is it's called Movement is the name of the firmware. And it's just a bare metal C program that just no RTOS, just a main loop, yeah. Anyway, yeah.
Very cool.
If anyone wants to check it out, it's open source. You can open a pull request, whatever.
Yeah. Awesome. All right. So I want to ask you, I know you've been manufacturing, you're coming up to manufacturing the last one. I want to ask how all the different batches have gone. How's your manufacturing journey gone? So you're nearing the end now, right? This current run is going to be the last one, or is there still more to come?
The second to last one. So the first run was the blue special edition boards, and that went really well. We manufactured 110 boards. I kept a few for like testing purposes, but we ended up shipping 89 of them out to backers, and then there's the one that you have that's for the giveaway. I don't know, someone canceled their order or something. We put 90 on the crowd supply site, and we got 89.
Foolish.
Yeah. So then this current batch is going to be 412 because that's the number of the 9-pin connectors that we have on hand. Unfortunately, those were struck by the parts shortage. So once we get the rest of those 9-pin connectors in, hopefully in November, then Cyber City Circuits is going to run the remaining boards.
How many were left? I missed the actual number.
I think it's going to be about 1,400 going to crowd supply. So some of those are for backers, some of those are for post-campaign sales, but
yeah. Because we buy a bunch. When a campaign is successful on crowd supply, we purchase like a load of them as well for sale on our site and also Mouse's site as well. Just to explain that. All right, so that's exciting. And you've obviously gone for manufacturing in the US with Cyber City Circuits. What were the decisions there? Because of course, like there's a lot of different options here, and then in the US, of course, you have it's a bit more expensive, but you don't get hit with tariffs and so on. So, like, what was your reasoning there for choosing to manufacture domestically with a small company?
Well, in this case, because Cyber City Circuits, they're a small company, they're a relatively new company. I was able to get a lot of I went down there and was able to be physically present when the object was manufactured, which is something I don't think I would be able to do if I were manufacturing overseas, or even honestly manufacturing with a larger PCBA house here in the States. But yeah, I mean, they're just good people, and I appreciated being able to go down there and work with them directly. And in fact, I'm working on, or I have this little Featherwing thing that I've done. LCD Featherwing, which we'll talk about later. But yeah, in this case, I was able to talk to them and get a quote for manufacturing, and it was more expensive than it would be overseas, but I feel like comfortable with the margins on it, and it works. So yeah.
Yeah, and I suppose like at the moment, so for those of you that aren't aware, in manufacturing at the moment, there's like a pretty punitive tariff that the US put on imports from China. So basically, if you've got a COO of country of origin of China, you get like a 25% import tariff when it hits the US, which can like take a big bite out of the amount that you save by manufacturing in China. However, I have seen that there's a movement in the Senate. This is a completely, well, it's not off topic, but a little slight diversion. But apparently that might get repealed this year.
I'm hopeful because even for importing things to make boards, like this LCD Featherwing,
the components, everything.
The display comes from China, so I end up getting hit by a pretty nasty tariff on that one.
Exactly. Yeah. I mean, I've seen people get really stung by that.
The thing is, if they repeal the tariff, then I'll be creating more jobs in America. You know, we'll manufacture here. Just let me get that part.
Exactly. You are a job creator, Mr. Castillo. Do you want to show us some of the things on your workbench? Can I add in the workshop tab? Because I'm desperate to talk about your jig.
Yes, definitely. So let's put the jig on the screen here.
Let's put the jig on the screen. In fact, I'm going to solo the jig. It's so exciting. There we go.
So this is this is the Sensor Watch tester that I've built to help kind of facilitate programming these boards. So originally, when I first did this, I just had a little cable that I would use to like kind of press onto these 5 test points, and it was kind of a manual process. I did it from an Adafruit Pi ruler. And it's, it worked for 100, but it's not going to work as well for, 1400. So this little gadget basically has these pogo pins here, and I can press the board down onto it and press this red button to flash the bootloader. And you can see the red light signals the bootloader is flashed on there. I can press the yellow button to put on a functional test.
Nice.
So that beeping is just beeping whenever a button is pressed. It tests the 3 colors of LED and the display. And then I can press the green button to load this kind of flashing light test. So this one's worth chatting about. So the sensor watch comes with this 9-pin connector, right? But this 9-pin connector down here. So each of those pins can do different things. So like it can be analog input, they can be
pull your hands a little bit down. You're cutting yourself off. Pull it down a bit further. You're just at the top of the screen. There we are. Lovely.
So this little 9-pin connector, it has power, ground, and 7 pins. So there's I2C bus. There's these GPIOs that can be used for SPI or analog input or whatever. And so I want to make sure that in tests that each of those pins is connected and they're not bridged to each other, because I would hate for you to get your sensor watch and then find out that the pins don't work. But I can't test that easily with just pressing down here. So I have this little tester board here that has LEDs for each of the pins. And so when I plug this in, they're going to flash red and green.
Oh, nice.
And I know that if I see any of the LEDs not light up, then it's going to fail that test and it needs to be reworked. Or if I see that 2 pins, like a red and a green, light up at the same time, that means there could be a bridged pin or some other problem. So this is the final test. And then from there, we can throw the laptop or the computer screen on here if you like.
Yeah, sure. You want me to put this one?
Yeah.
Okay.
And from there, you can just download firmware images onto the watch. So here I'm going to download, let's say actually, last time I did the live stream, we were doing astronomy stuff. So let's, I was beginning with the astronomy stuff. So let's do the Stargazer here.
Yeah.
So this is a firmware that has the clock, astronomy watch face, sunrise, sunset, and moon phase. So we're going to download it for green boards. And let's see, downloads the Stargazer.
I love seeing people's tests and jigs. I always learn so much.
So I'm going to just put the watch in bootloader mode and drag the Stargazer over.
Nice.
And so now if I push this onto the tester board, you can spotlight that. You'll see the...
I will spotlight 1 second.
Oh, right. I need to take my test board out. you should see the Stargazer firmware running. Yeah, right there.
Yes.
So
fantastic.
I actually have it loaded up on here on the Gold Watch. So yeah, when I was when we were last doing the live stream, I just kind of made a UI test for the astronomy watch face, but now it's actually functional. So let's
so exciting.
Say Mars here. It's like that MA at the top is kind of tough to focus on this. There we go. MA is for Mars there. So I'm going to do the long press here, and it'll calculate the altitude, azimuth, right ascension, declination, and then the distance between Earth and Mars in astronomical units, which is a pretty cool thing. Like if you were in the backyard of the telescope,
really cool thing.
If you were in the backyard of the telescope, you could plug in this right ascension and declination into your telescope, and it would zoom over to where the Mars is right now. So yeah, I think it's cool to take this little Casio wristwatch that costs less than $20 and yeah, make it into a astronomy machine. Like NASA has a supercomputer system for this, and you can put it on your wrist.
You should get one to Mars.
Yeah.
That's super cool. Thank you for showing us the jig.
Oh yeah, for sure. No, this jig is fun. Yeah.
There's a lot of love for the jig in the comments, I've got to say, and here as well, and in this side. Yeah, we've got some questions here. So we're saying, oh well, there's a question from Guy about the tariffs, but then David already answered that one. Noah says that's a fancy jig. It looks like a product in its own right. I absolutely agree.
It's a product with one user for me,
Yeah, exactly. Should do a crowdfunding campaign. Goal 1 on sale. Thomas also enjoys the jig, as does Benny Blue, as does Johannes. But he's got a question saying, how much work was it making the tester, and how much time did it save you?
It was a couple of days, just doing the PCB routing. It's actually, we kind of zoom in here. The LCD routing was a little bit, yeah, you can kind of see there.
Yes.
It looks like a harp or something. It was a little bit annoying to route, but yeah, it was relatively quick process. A couple of days of design, and then like just one day of building it. Using the Adafruit PewDiePie here was actually a huge time saver because it's a castellated module with like all the power supply and microcontroller. So I didn't even have to worry about like, figuring out how to like bring up a microcontroller. I just like solder this module on and it's done. So yeah, it was
great.
I mean, how much time did it save me? I think it's going to save me a ton of time. Like just being able to press these 3 buttons and do those tests really quickly, instead of like aligning my test pins and all that stuff. It's gonna be good.
A couple more compliments here, saying the whole firmware process is so slick. Lots of hand clapping. And then Robin, hi Robin, nice to see you. Nothing better than an OS independent firmware update via USB mass storage.
Totally.
I agree. Fantastic. And then Benny's asked, are you going to flash every watch yourself, or do they do that?
Yes. So basically, the way that this test setup works, the red button tests just the smoke test, make sure the bootloader works. The yellow test tests out the LCD and the buttons. The green test tests the sensor board. But at that point, I still haven't tested the reset button or the USB. So the final step in this test is I double tap the reset button to put it into bootloader mode, and I copy over the firmware. And that tests every feature of the watch and also flashes it with a working version of Movement, the community firmware. I will flash every watch myself because that is the final test.
Wow. And this is like handcrafted hardware. It's hand tested and flashed by your fair hands. How lovely. Oh, I've got a couple of good questions here as well. So this one's quite an interesting one. So is there any extra space inside the watch bezel to include other sensors? So do you want to show what those sensors look like, Joey? Because I think that's an interesting question.
So yeah, basically, actually, let me
spotlight
I've lost my little bag of stuff. There was oh, here it is. So if you look at the inside of the Casio F-91W thing, I guess this is the watch. The plastic housing that the watch fits inside of. You'll see that there's kind of a little cavity here, And one of the things that we use is this 9-pin connector has this room for this L-shaped board that goes over to the right. And there's this little tiny, it's about 6 millimeters by 6 millimeters. Where is it? There you go. You can see this little cavity right here. So it's 6 millimeters by 6 millimeters by about 1 millimeter tall. And that's the room you have for extra sensors. Not a lot of room, but the board, the sensor board comes with the crowd supply campaign, or it did during the backer phase, is a temperature sensor board. So it's just a thermistor and a high precision resistor to make a voltage divider, which can measure the temperature, ambient temperature, useful for throwing outside your tent while camping to see how cold it gets overnight. I also am playing with a light sensor board, which the transflected LCD does let some light through, and you can even see the fact that light gets through from the back means that light can get through from the front. And then I'm also playing with an accelerometer one, which would be really interesting for machine learning stuff and action detection, maybe even gesture detection, like moving your arm around, waving my arm like a madman here, but you can't see.
Oh yeah, sorry, because I've spotlighted the. I can remove the spotlight, and we can. You can wave away as long as you want.
Yeah, I'd like. Oh, sorry, good.
Yeah. Yeah, no, I was just saying that the space is extremely limited, but you've made the most of it by using flex PCBs to add in your little daughter boards there.
Totally, yeah.
Do we call them daughter boards still? That's what we call them, right?
Call them.
I don't know.
I'm calling them sensor watch accessory boards.
Well, there we are. That's what I will call them as well. Here we go. There was another question I wanted to ask as well from the thing, which is, does the SAML board come ready to go with UF2, or do you have to flash that third? And I'd actually like to expand this question slightly, because I've actually not worked with SAML before, and that's what you're using to drive the LCD, right?
Yes. Yeah. The L21 is just a
what other things does it do?
So yeah, the L21 is a really low power microcontroller. The L22 is similar to the L21, but it adds the LCD controller. So yeah, the L is for low power, basically. And yeah, it does not come ready to go with UF2. So I do that pressing that red button on the tester, that flashes the bootloader, the UF2 bootloader onto it. Nice. It is interesting though. Microchip does offer a service where you can send them a image that you would like flashed onto a chip. And if you're so if I were ever to do a big run of 4,000 or something, I could send them a firmware image and they would flash that onto the firmware before it even gets reeled. So that's an interesting possibility.
Oh, really?
Yeah.
How much do you know how much that costs? Is it?
It's on the order of expensive. Yeah, it's on the order of a few, it's something like 20 cents per unit or something like that. I don't quote me on that. It's on their website.
No. I was just interested in the ballpark.
A little bit, yeah.
Is there a minimum number of orders that you have to do in order to access that service? Do you know?
Or I do not know. Yeah, I actually haven't had a chance to order these direct from Microchip yet because we went through Mouser for this run. Wow. But it's something I'd be interested in the future, because one thing is, you need, right now, if you see the little kind of test points that I'm using to flash this thing, I have to have those test points because there's no other way to access the SWD pins that you would use to flash this on. If it came from the factory flashed with the UF2 bootloader, then I wouldn't have to do that, and I could use that space for something else.
Imagine the possibilities with extra space, my goodness. All right, so let's see. I wanted to, before we get too distracted with all the questions, and there's great questions, and I will come back to them, but I wanted to see some of the other stuff that you're working on, because I know you've got this Featherwing, and I wanted to see the open book, which is one of my faves of your projects. So I will come back to other people's questions. So please do keep asking your questions. I just want to make sure that we take a look at some of the stuff that's that Joey's working on right now.
So this is the LCD Featherwing. Basically, I realized after working with the sensor watch for a year, I kind of know stuff about LCDs now. So I figured I would like to go back to my roots and make a Featherwing with an LCD. So this, right now it's illuminating all the segments. You've got your 5 7-segment digits, you got a colon, and then you got 4 decimal points in between, as well as some icons, negative number symbol. So yeah, it's really useful for doing things like a clock, here 12:34 p.m., or an alarm, which this little bell at the top left. I'm not sure you can see.
Let me. I'm going to spotlight you. Let's look at Let's look at the hardware, not our faces. More interesting.
Yeah, so you can use it to display some, words like your Wi-Fi and a little Wi-Fi icon. You can display sensor readings. Sorry?
It's pretty crisp.
It's very crisp. Yeah, I did some macro shots of the screen. It's just it's really beautifully crisp. So yeah, just kind of this is just a demo sketch to show some of the different kinds of things you might be able to put on it. Temperature sensor, relative humidity. My very creative use of the symbols make a % sign. Kind of works.
Yeah, it kind of works.
Kind of works, yeah.
Yeah, totally.
So yeah, so that's the and that's the other interesting thing about this. The reason I wanted to do this LCD Featherwing is there's a lot of display tech out there. The Adafruit has like a TFT wing. They've got an OLED wing, which are all very cool and very versatile. But you don't get the kind of low power consumption of an LCD. So like an LCD, this Featherwing draws on the order of 12 microamperes of power, even with the display on. So with something like this ESP32 that supports deep sleep, you can run your CircuitPython code, go into deep sleep, and be consuming very little power. I just completed a battery test on this where using this tiny little 400 milliampere hour battery that just it just fits like in between the feather headers. I was able to get 16 days of battery life.
Board, or what is that?
Sorry?
Is that a power management? Is that just a power management board? Oh, actually, we've got a question about that. Saying, what are the other boards that you have there with the Featherwing? What is that one?
So this is Adafruit's ESP32 S2 feather. So it's it's a Wi-Fi enabled feather with it supports deep sleep. So yeah, this was the kind of board that I used for my battery test, where I was uploading data every 15 minutes, and the display was always on, and it got 16 days of battery life, which is pretty decent for something this compact.
That is not bad. That is not bad. And what's the other board on the bottom there? That's also one of yours, but
this is also one of mine. I haven't put this up for sale or anything yet. It's just a button and buzzer board. So it's just 3 buttons and a piezo buzzer, all parts that you can get from Adafruit. But yeah, it's basically if you want to do something low power and you don't want to have something like a what am I looking for? Words here. Words. You don't want to have something like that. Like I squared C to work. You just want some buttons tied to some inputs. It's just a simple button board. And
I like the button board.
The buzzer's nice and beepy.
Yeah. Yes, it is nice and beepy. Brian Kobe, hi Nessa, thanks for joining us. It says hi to both of us, saying he's loving his Featherwing and that LCD is perfect for low power projects. So
awesome, glad you like it.
It's nice to see people using these things out in the world, isn't it? And also, there's some exciting open book questions coming in early. So do you want to show us what's been going on with your open book? Give us a little bit of background into this project first, actually.
So this is let's talk about it. This is my long-standing quest to build an open source ebook reader, and it was kind of my first real project. I just didn't know enough about making things to make it make sense at first. So I kind of threw the kitchen sink at the first board. It had way too many parts. It was way too complicated to assemble. And over the course of time, I've been kind of streamlining and simplifying. And the current version of the open book is this version with the Raspberry Pi Pico. Let me turn this on.
Interesting. Well, it's obtainable.
It's obtainable. That's the main selling point. I'm looking for these days. So it's I'm in the process of writing this kind of GUI framework for it. This is a event-driven GUI where it's like taking my button inputs and turning them into events. So I'm going to press here. Yeah, the last task that I was talking about was pagination. So basically, I'm trying to make it. So actually, let's spotlight this, but also this computer screen.
Oh yeah, do you want me to bring up this computer screen as well?
Yes.
Oh yeah, look at that. Oh, we've got so many things.
So my goal is for the kind of canonical format for these books to be plain text. So this is The Great Gatsby, and actually let me load this up in VS Code. It's easy that way. So yeah, basically I've got this kind of YAML style front matter, Great Gatsby, Scott Fitzgerald, genre language. And then I'm using these, what do you call these? ASCII special characters.
Oh, are they not too? Oh, yeah, I see.
So that RS stands for record separator, and it's just an ASCII control code from the very low, like first 32 or 20 or whatever, first few like ASCII codes. This was used back in the day during like the era of like punched tape, where you would have like record separators separating things out and file separators. But I'm in this case using it to signal the breaks in chapters. And I'm also using.
Why did you choose to use that protocol or that?
Because I'm like I want it to be plain text. I want to keep like the idea of like ASCII/UTF-8 text as being like the canonical format for books. I don't want to invent a new ebook reader format. The world needs another format. Like it needs. Well, the world doesn't need another format.
Accurate.
Yeah. So basically, back to the main camera. It comes in as plain text, but I've got to break it up into pages so that the user can actually like read pages. So this is a process I call pagination, where it kind of runs through the entire book and paginates it. So it like kind of breaks it up into positions and like locations and lengths of pages. So here I've got my test file loaded up here. And if you want to go back to the main camera, you can see.
Yep, sure. Here we go.
So it's broken the book up into pages, and so now I have page 1, page 2. It's still a little glitchy. It's not quite where I want it to be yet. That's the last thing I need to do to make this open book actually work well. But I mean, I've got it to the point where I can load up The Great Gatsby, have chapter breaks. Yeah, this is my glitch where it's got the wrong text in the chapter title, and then I've got this one page that just looks like gibberish in a second here. But yeah, that's the state of the open book. It's a work in progress.
Very attractive. Yeah.
Thank you.
I like the fact that you've simplified it a lot. Are you planning on doing a casing with it, or like just doing an SDL file that people can 3D print their own case? Like, what are your plans for actually? I know it's already got a 3D printed case. Yeah, what are your plans for the actual manufacturing of this board?
I don't know yet. This first version, the one that takes AA batteries, my goal is to get it to be. Let me take this apart really quick. Get the PCB like out there and like basically make it a kit that people can build themselves. Because right now the goal is I just want people to be able to like have the hardware and hack on the software. So this would not be a manufactured good quite yet. It would more be a DIY project.
Yeah.
Part 1 second.
Well, while you're fiddling with that, I've got some great comments here. So David's saying, "Well, I've never run into RS, and me either." So that was a pretty interesting piece of ASCII history there for me. Actually,
there's a lot of interesting little.
It is very
Yeah. But one other one that I'm using is the shift in, shift out. So. This is like if you open this in just a plain text editor, you wouldn't see these characters. They would just disappear because you know who uses ASCII control codes these days. But back in the original like days of teletype, when you had the red phone ringing in Moscow, you could use the shift in character to either shift in a Russian character or a Cyrillic character set, the alphabet, or you could use it to print in different colors. So like you would have a shift in to use the red ribbon and a shift out to return to the black ribbon. And this was useful if you had a very important message that needed to be emphasized. But here I'm using it to italicize the word candles here, rather than trying to use Markdown or HTML, use the shift in character to do what it was originally meant to do, shift the presentation of a character. But that is, again, like one of these old school ASCII control codes from way back in the day.
Yeah, and actually that's a really good point to bring up this comment, which I really liked from Noah Hoffman, saying, "I love that the open book harkens back to the time when programming was paper." So I do actually, it's quite fitting that you're using these ASCII commands from back in the physical computing, back in the old days.
Hadn't thought about it that way, but yeah, I love it.
no, but it's nice. I like it. And Taki B is here. Hi, nice to see you again. Quite late, but hi to all. Fantastic. Dan Delaney also here saying hello. Hi.
Hey.
Danny has said, "Is that electronic paper that you're using? What is the screen that you're using?"
This is e-paper, yes.
Someone's asked e-ink, e-paper. E-ink is the brand name, isn't it?
E-ink is a trademark, so I try to avoid saying it.
Yeah, for sure. So there we are. And a good question here from David saying, do users have to do it, or does it take something from Project Gutenberg or whatever and it just does it for you?
So I am.
Basically, this is the beginning of the question. It's like, when does this manipulation happen to the file? And like, if what does it take something from Project?
So what I have here is EPUBs from standard EPUBs, or standard ebooks, I think is what they're called. I think it's standardebooks.org, although just Google it and it'll come up. But they have really good formatting in their ebooks. Like they're just really well put together. So I'm using those as my source to create the text files. So I don't know, why can't I find my? Oh, it's. I'm confused by my multiple screens here.
It's all right. We're also doing this live whilst having a conversation with like several different comments and windows open. So it's okay if you've misplaced something.
So I've got this Libros Convert, which is a.
You've made a little script.
Yeah, I've made a little script that basically it just takes the ebook and it converts it to a text file. So actually, I'm not even going to bother to. Well, maybe I can. Python 3 convert, and I'm going to convert F. Scott Fitzgerald. So yeah, I have this little script that where you can like check off which chapters you want to export, and then it turns it into that text file that you see, and then the pagination happens on device. So yeah.
Nice, very cool, very exciting. So
ideally, I would love,
go on.
No, I would love for some of these public domain works for this like standard text file format to become kind of a canonical format for ebooks, because text is like the most universally accessible like file format. It's UTF-8 text. It's international. It supports everyone's language. It's not going to be obsolete anytime soon, I hope.
Well, yeah, who knows? But no, I agree. It's been around. It's been sticking around for a long time, and it's still in use. So it's all very exciting. Oh, another good question here from Brent saying, "Is EPUB to text hosted anywhere? I have librarian friends who would love this."
It is. It's a open source GitHub module, or Python module. It's not. I didn't write it. It's who wrote this? I don't know. If you Google EPUB to text, it's a Python module that's out there.
Okay, good, awesome. So, is there anything else on your desk you wanted to show me, or should I just go through? Or should we ask more questions?
No, we can ask more questions. I've got. Oh, I guess I would show the backside of the open book.
Oh yes, yeah. I wanted to see that. Let me solo it so you can see that. Show me that. Can I just take a moment here to give you some praise for your silk screens? Because I love your silk screens. I love reading your silk screens. I love the fact that you put information on your silk screens, unlike some people, Raspberry Pi, who don't even put their pin numbers on their silk screens. So yeah, just a quick bit of love there for your lovely silk screens.
Thank you.
Joey. So yeah, show us around the back of your board, please.
So this silk screen is actually different. The other ones used to like try to explain what each part did. This one is actually just instructions. So it's like step 1, solder the on-off switch. Step 2, the reset button. And I've really tried to like simplify this design to the point that it's not, I mean, I can count the number of parts. There's the switch, the button, there's 2 MOSFETs and a capacitor that gets the power supplied to the board. There's a language chip, a pull-up resistor, and another decoupling capacitor, lock button, micro SD slot, capacitor pull-up, and then you have the Pi Pico and the castellated module for the e-paper display. That's it. I assembled this in about 20 minutes, and I think I've finally gotten it to the point where it's reasonable to tell folks you can hand solder this book. So
that's exciting.
Really stoked to get this one out. Yeah.
No, that's really exciting. And is that castellated module? Does that come with attached to the display when you purchase it, or
no? I designed this castellated module. I'm going to have them manufactured and include that with the kit.
Nice. I see. Very cool. Yeah. And what you said? Language chip? What do you mean? Language chip?
It's really just a 2 megabyte SPI flash chip. But what I use it for is basically the entire Unicode basic multilingual plane. It's every language, like not every language. There's a few that are in the extended plane, but for the most part, every language that is spoken by an appreciable fraction of the world is on this chip. And so you can display works in English, Spanish, Russian, Arabic, Hebrew. Like it has. Yeah, if name a language, it's probably on here. It even has like the Cherokee languages in here. So the idea is, and this is actually, oh yeah, insert micro SD card. My thought process behind this was, you know, in the history of computing, we've had this kind of bias toward like Western languages. Like ASCII was just designed for Western languages, and if you had a work that was not a part of that like character set, it kind of was a second-class citizen. And so in this case, all languages are rendered using the same code path. So like this page that has all the titles of all the books is rendered using the exact same code path that would render titles of works in Russian or in Arabic. So yeah, basically the language chip is my way of saying, sorry, good.
No. I'm just how do you do, because you know obviously some languages read the other way, right? And how are you tackling that problem? Because I know that back in the day, I actually used to work in publishing 100 years ago, and I did a lot of stuff with EPUBs when they were early days.
Yeah, so there's two cool things here.
Back then. Yeah, so please update me.
Number one is the code has specific cases to deal with right to left and left to right. And the Unicode standard also specifies which characters will flip the direction. So that information is also encoded onto the language chip. And so as I'm doing a text run, if I encounter a right to left script, it goes to the next line, it resets to the right side of the screen and starts laying out right to left. The other really cool thing, let me see if I can pull up my, it's on the laptop screen.
Yep, I'll bring that in.
Open recent, Libros, don't save. So in the, zoom out here, in the language library here, there is a whole section dedicated to Arabic shaping. So one interesting thing about Arabic script in particular, in addition to it being rendered out from right to left, all of the characters, it's kind of like cursive. The characters have to connect to each other. You would never display like an isolated letter B. It would have to be connected to the letter before it and connected to the letter after it. So, where is my Arabic?
I did actually typeset a book once in Arabic, and it was extremely difficult. Because of this cursive thing, like the fonts I was using were not able to handle it particularly elegantly.
I can't find my Arabic shaping. It's in here somewhere, but basically, yeah, it's a whole series of test of. Let me just pull it up.
While you pull it up, I'll bring in some comments here. So Taki B said that EPUB detect is also easily done with Calibre.
That's true, yes.
And David says that I have a DOS-based app that I want to try this with. How fun. Some love for your silk screen here from Noah Hoffman. I fully agree. I couldn't agree more. Oh, and a good question here from David. Why are you using regular batteries?
That was another part of my simplifying the design. So if I use a LiPo battery, then I've got to add a LiPo charging circuit. And it also complicates shipping because the battery I was using was kind of a custom LiPo.
This is true.
And you can't just ship those in airplanes.
You cannot, particularly if it's in a kit. It gets very complicated for import and export when you add in a LiPo in a kit.
Yeah.
You know.
So in this case, it runs on rechargeable AAA cells. So you can take these batteries out, you can plug them into a charger on the wall.
Oh, nice.
It also lowers the cost because now I'm not adding a charging chip on my board. You're just bringing your own charger from outside. So that's the.
Well, that's a very good segue as well. Unless you find, if you find your scripting,
I did. I forgot.
Okay,
it's part of the original.
I'll come back to the,
it's part of the original conversion to from like it's part of the burning of language of the flash chip. So the code's actually not annotated in the. Anyway, long story. Point is. There's a whole section in my converter script that deals with the Perso-Arabic shaping, and if you want to, this is in the Bezel repository in my GitHub, and it's kind of a little lesson on how Arabic and Persian scripts connect to each other.
Very interesting. It is really very fascinating. Okay, so there's quite a few people who have asked similar questions. including Noah Hoffman. Actually, with this comment, Noah, you are winning today's mystery hardware box full of swag. Actually, I'm gonna remove this for right now so I can show you what you get in your box. What we got today, we have got some very exciting. Everybody loves technical socks, so we've got one of my favorites. Technical socks actually here. So we've got I Am Changing My Bomb Again. These are socks from Screaming Circuits, who are actually my next guest. I'm doing a factory tour of the circuits, the Screaming Circuits on our next episode. What else have you got? You have got some laser cut bandami things, whatever those are. And we also have a little monster LCD screen from Adafruit. So yeah, you know, the little heads with the LCD screens on the front. So you get one of those, and you also get like some stickers and some swag as well. And of course, the star of the show is the limited edition sensor watch. So that will be on its way to you. If you can send me DM me your full name, address, and phone number on Twitter, either my handle, which is Helen Leigh, Leigh, or Crowd Supply, just DM either of us and send us your details, and we will get that sent out in the post to you. So congratulations. But also, there were a few people who asked this about the bomb price. Have you got any idea of your kind of bomb price at the moment?
I don't offhand. I've been simplifying it a lot, but I mean, one of the good things about using the Pi Pico is the USB port is included. The little LED is included. Like you get to reuse, like the power supply is included. You don't have to buy each of these individual parts. The Pi Pico has all of this stuff for just $4. So I don't have an exact number on the bomb price, but I've been trying to make this as affordable and accessible as possible. So I sense that it would be under $50 at this point.
What? That's going to be amazing. I mean, obviously you've got to, put stuff on that, but a $50 bomb price for an open book, that would be incredible. Johannes is saying this looks like something even I could assemble. It does actually look very accessible, definitely. Yeah, and then this is my favorite comment. Dan said something that I've already thought. It would be really fun to invent a text format for choose your own adventure books on this thing. Yes, it would.
Yes.
I fully agree. I'm a big fan of choose your own adventure text formats. It's all good. And Taki's also said, I love informative silk screens. And does the oddly specific object mascot have a name or species? That's a very good question. Do you want to show the little creature on the so people know what we're talking about?
Little oh, here we go.
Hang on, here
she's a bear and a shark. I think they're friends. Haven't given her a name though.
Maybe we need to name her on today's stream. Might be the next time. Like that. Yep. So okay, no name, but it's a Bearshark. So informative. Only the hardest hitting news on the Teardown Sessions. Some more love for Dan's idea of text adventures. I feel like oh, Dashipu saying good to Arbig. Dashipu, nice to see you. Yeah, I love it. And your code is well documented as your silk screen. Got a lovely today an epic code.
I do these things for myself, honestly. It's nice to be able to how did I do that? Oh wait, it's commented. It's on the silk screen.
Seriously, I look at my old projects all the time when I'm like, how did I do that? I've got literally no recollection. And I look at it and I'm like, thank God I've documented it. So you document it for yourself, and it's useful for other people for sure. Mm-hmm. Another question with it: will it have a Pico W and a text web browser?
Nope. No, I've ordered a Pico W to play with and see if it'll work. But the fact is, the way that this is designed, if the USB port's going to face out, the antenna is going to be kind of buried in the middle of the board and be surrounded by a ground port and other stuff. It might work, but I sense it's not going to be the best experience for Wi-Fi. I will at some point design a version of this with an ESP32, and that'll probably be the way we do Wi-Fi. But web browser, I don't know. Was that? Yeah, V2, exactly.
Yeah.
Yeah, web browser's tough. Like HTML and all the parsing and stuff. I'm not sure if a microcontroller is going to be able to do all of that stuff that you would want, but I do like the idea of bringing in feeds or JSON or something. But web browser might be tough.
Yeah, and the follow-up of us saying denied, functionality removed.
I also, part of my whole oddly specific object spiel is you have a laptop for browsing the web, and like you like the watch. It's like it's should be simple and all the time and last as long as it can. I'm making a trade-off by not making it smarter, you know. So yeah, for the open book, it's like it's for reading text files, and I like the idea of being opinionated about what it is and what it isn't. So yeah,
I agree with you actually, Joey. And you know, it's a specific object, so you are following your own brand. All right, so we are at an hour. It always goes so fast.
Where does the time go?
Actually, I know. So if anybody's got any final questions you want to sling in before we head off, now is the time.
I see a good one here.
We do have one. Yeah, we have exactly. So Builder a Rat says, for the sensor watch, do you know if anybody has implemented data export using the LEDs yet and the corresponding photo transmitter on the computer Arduino to read the data?
I have not seen anyone using the LEDs yet, but I have seen a very cool project where someone used RTTY, radio teletype, to use the piezo buzzer to beep out data. And
nice.
It sounds very cool. It's this guy, he's ordered the watch. He doesn't have it on hand yet, so this is using a microcontroller board and a piezo. But I see no reason that it wouldn't work the same way in the watch. It's a piezo buzzer. It can do multiple tones. RTTY is going to get data off the watch. I can feel it.
Yeah. Oh, so exciting. So cool. I love it. And another follow-up from Johanna. So the watch is not going to have a web browser. Is this what we're what we're learning today? There's no web capabilities on your Casio.
Yeah.
I don't think you could fit an ESP32 in there, even the smallest package. I don't know, maybe. But there would be room for nothing else, I think.
Yeah.
And someone probably has a micro-sized implementation of Mosaic browser somewhere. Yes.
I mean, I'm also like, if you load up Mosaic, like you can't actually browse the modern web using a browser from '94. Like the web has just moved to this like incomprehensible place. So I don't know.
And to be perfectly honest with you, also, if it's open source software and open source hardware, so if you really want a web browser on your open book, you can go on ahead and
that's very true.
Implement it yourself. Like, you know, the functionality is limited to your own abilities and ideas for sure. All right, so one final comment here. We got a text-only browser on the HP20. It's dope. I like it. Text-only stuff is cool. I really like the idea of the text-only EPUB files as well. Oh, that's very cool. All right, it is time to say goodbye. I've had such a lovely time with you, Joey.
Blast, yeah.
Where can people find out more about you, and where can they find your stuff? So I know I've got the GitHub thing here, and are you just tweeting out stuff? Is that
I just tweet out stuff. It's at Jose Castillo on Twitter, not Joey. This GitHub is correct.
Oh yes, it is.
The GitHub is correct, but the Twitter is at Jose Castillo. And I actually just put together a new website at oddlyspecificobjects.com. So that has documentation on the Featherwing and the sensor watch, as well as kind of a very opinionated about page.
Is that your Twitter?
That is it, yes.
Okay, let me just bring up the website as well. She says typey. Here we go. Yeah, lovely. So the oddlyspecific.org, yeah?
No, it's oddlyspecificobjects.com.
Oh.
I gotta fix that. The old one needs to redirect.
Oh, I see. Yeah. Oh, sorry, there we are. Okay, add banner. So if you go to here,
oddly specific objects, oddly specific objects.
Oh, lies again. Here we are, objects. Oh, I see. So you got the old one. It's just oddly specific, and then
yeah.
Here we go. This is the actually correct.
That's the one.
Here we go. So yeah, so there's the GitHub, which is the Joey Castillo. There's the Twitter, which is the Jose Castillo, and then there's the website, which is oddlyspecificobjects.com, which has all of that good stuff on there. Thank you so much for your time.
Thank you.
Congratulations on your new website. Congratulations on getting to the final parts of manufacturing for your campaign. And also, like, how are you managing to do so many projects all the time? Like, it's incredible. your output this year has been astronomical. You know,
I feel like I've been focused.
Burn yourself out. Yeah, yeah. I mean, being focused is good, but don't burn yourself out. We need you for the years to come, you know? Yeah, it's awesome. All right. Thank you so much, everybody, for joining us and keeping us company. We've had so many lovely comments and questions, and I hope you felt the love, Joey, because
I definitely felt the love.
Good. That's the aim. We aim to nerd out and help you feel the love, because there's lots of people who really admire what you're doing, me included. So thank you for joining us, and thank you for doing your work. And I will see you, I'm sure, next on another occasion on this live stream. You're always such a lovely guest. So
for sure.
Thank you for joining us. I hope you had fun.
All right.
All right. Bye, everyone.
Bye, y'all.
Really nice to meet you. See you later.
Yeah.
Oh no! I forgot to say about the next stream. It's not next week. Next week I am at Tour Camp. If anybody else is at Tour Camp, I will be there. I'll be doing a workshop, and I'm going to give a talk about soft electronics. We're doing soft robotics at Tour Camp, which is an outdoors hacker camp, just slightly north of Seattle. So I'm going to that. And the week after that, I'm going to be doing, I think it's the week after that, but I'll double check. Well, I'll be doing a factory tour of Screaming Circuits, which is a local circuit manufacturing service here near Portland. So yes, so please join me again. But yes, thank you very much, and see you later. Bye, everyone.
Bye, all.
Cheers.